Hey folks, today we're going to talk about heating and cooling curves. You'll remember that there are three states of matter: solids, liquids, and gases. And we classify those based on how much energy the particles of the substance has. So the more energy, the more those particles can move. And all these particles have an attractive force that hold them together. So if they have less kinetic energy, the attractive forces make the particles stick together, like in a solid. As you increase your kinetic energy, then you can overcome those attractive forces, and the particles can flow like in a liquid, or they can bounce off each other and off the walls and be far apart like in a gas. You'll remember that temperature is a quantitative measurement of how hot or cold something is. The more energy you have in your particles, the higher the temperature ends up being. So when we're looking at matter changing states, there's a graph that we use to talk about this. It's called a heating and cooling curve. So what we do is we take the temperature of our substance on the y-axis and the time as we're heating it up, the substance, or if we're cooling it down, on the x-axis. When we're all done plotting our data, it's going to look something like this. Down here we have a solid. And as we're heating that solid up, it starts to melt around here. Or if we're going backwards, it'll be freezing. Once all of these substances melted, we have a liquid. And we can heat that up, and at this point, the liquid is turning into a gas, so it could be condensing if we're going from a gas to a liquid, or evaporating if we're going from a liquid to a gas. At this point, we have a gas, where the particles are far apart. So as we're looking at one of these heating and cooling curves, you can notice that at the very bottom of the curve, that's the coldest part, and that's usually where you're a solid. So right now, I am a solid sitting here on this curve, and I'm being warmed up by some outside process. And you can see that my particles are moving faster and faster, and as I get up in temperature, I can start to turn into a liquid. At this point, I exist as both a liquid and a solid. Some parts of me are liquid, some parts are solid, and I'm going to stay this way at this temperature for a little while. Once I've turned completely into a liquid, now you can see that I'm warming up again and my particles are moving faster, and my temperature is increasing because I'm going up the graph. At some point, you can see that I'm turning into a gas. So now some of my particles are flying off and bouncing around all over the place, and I'm going to exist now on this flat part of the graph at this exact temperature for a certain amount of time as I'm both a liquid and a gas. Once all of my liquid is turned into gas particles, and now I can heat up again and become a much hotter gas. So as you're looking at these heating and cooling curves, you can see as it's being warmed up, there's a flat part over here. There's also a flat part up here. These two flat parts are the melting and boiling points of whatever substance we're looking at. So if you're asked on a homework question at some point, what's the melting point based on this heating or cooling curve, then you know it's the flat part that is the between the solid and liquid portion of the graph.